Hello everyone, my name is Kevin Williams with TechSelect.com, and we're proud to introduce our latest product, the Resound OPL3 card. What this card is a sound card similar to the Ad-Lib. The Ad-Lib originally used a chip called the Yamaha OPL2, and this is actually the next version of the chip, the Yamaha OPL3. It's backwards compatible with the OPL2, so it'll work similarly to an Ad-Lib card, but it also offers more features than the OPL2, and certain programs do take advantage of that. There's a few other features on this card that don't exist on any other card that I'm aware of. One of those is I have an entire bank here of dip switches, which will allow you to set the base address for the card to anything you like. Right now it's set to 388, which is the standard port that the Ad-Lib uses, so it'll actually act as if though it's an Ad-Lib card for any application that wants one. But in addition to that, the OPL3 supported stereo, and it actually supported a mode that I don't think a lot of people knew about, which is 4-channel mode. From what I can tell, there were never any commercial sound cards made which actually supported the 3rd and 4th channel, but we went ahead and added it here because I know that there's a great retro gaming market coming up, and as people write new applications, it's my hope that they'll be able to take advantage of the surround channels that are available on this card. So the sound chip is actually right here, and if you'll notice, there's actually 2 copies of pretty much the same circuitry. The OPL3 chip supported initially 2-channel sound, and it did so by using one external Yamaha DAC chip, and then it actually used an external bit of circuitry which is in the data sheet, and then I put on a small buffered op amp on the output to make sure that the sound output level was correct. And if you see here, there's just a second DAC chip and a copy of the same circuitry again. So we went ahead and added it here, and most of your programs that exist already really aren't going to make use of that. We're just hoping that down the road some people will. We've also used WEMA capacitors, and these are actually high quality capacitors that I kind of learned from building different stereos, or learned about from building stereos. They're film capacitors. Most of the sound cards use electrolytics, and there are good quality audio grade electrolytic capacitors, but I've decided that just to make it as clean as possible to go ahead and use the higher end capacitors for filtering. In addition, decoupling capacitors, not to get too technical, but what they really do is prevent DC current from flowing and only allow AC to flow, which in this case is an audio signal. So these guys have a input decoupling capacitor and an output decoupling capacitor. Generally you'll only see the output, but what I was noticing was on my prototype boards I was getting a little bit of noise from the digital section leaking in, so by putting these capacitors in front of the amplification and then putting some after it to the output, I've done a fairly decent job, I believe, at blocking most of the DC. Now obviously a lot of factors will prevail, what other devices are in your computer, anything that's adjacent to it possibly could cause interference. And this card also pulls plus and minus 12 volts from the power supply to power all 4 of these chips. And as a result of that, if your power supply is generating a lot of noise, those chips are going to pick it up. In addition, we've put decoupling capacitors across the power lines on both rails of both of these chips, and that's why you see kind of a lot of what looks like extra circuitry on there, but it's really just an attempt to make sure that the sound is as clean as it possibly can be. Another thing that we've done is we went ahead and right here, this is a small 14.3 megahertz oscillator. Generally the sound cards pull that oscillator off of the bus, but when I did some research I found that some older machines don't actually supply 14 megahertz to the bus, and I wanted to ensure that no matter what machine you put this in, you would actually be able to support full range sound. Otherwise it would actually change the frequency of the card because it's using that oscillator to base the notes off of. So basically you should be able to put this in an IBM 5150 all the way up to any modern machine that has an ISA slot, and it should behave just fine. Now that I have the card turned over, you can see that it's fairly boring on the back, but it does have the dip switch settings, which tells you the default address, which is 388 for Ad-Lib, and it also shows you what settings you need to perform in order to make sure it's set back to that. So if you do change it around be aware that you can always look on the back of the card and change it right back. So what I'm going to do now is I'm actually going to install this card in my Packard Bell XT based machine. It does have an NEC V20 chip, which makes it run somewhere around 10 to 11 megahertz. I don't remember exactly how fast it is, but I'll show you that if I put it in turbo mode or standard mode, which should be running closer to 5 megahertz, the card will actually still operate. But I have actually run into a few situations where playing back complex MIDI files, such as Flight of the Bumblebee, for example, in a MIDI format, the machine actually drops notes and slows down. So even though it'll work in older machines, your machine may have to have, you know, a fairly fast processor in order to make sure sound can keep going to it. But one of the demos I'm going to show is that the card will actually play Space Quest 3. This is the inside of my Packard Bell, and sorry for the dust. It's a test machine, so it's open more than it's closed. But also you'll notice the low-tech card, which is the compact flash adapter, and I just have a adapter sticking out of the side of it. And here's the actual sound card itself. Just so I can show there's no smoke and mirrors, I'm going to go ahead and install it. I'll even have a tab on this one, so you can put a screw in to secure it. And for now, I'm just going to plug in the left and right channels. Which in this case is the top connector. And I'll show the back of the machine in a little bit. But for now, I've just got the first and second channel, what the normal sound card would have, plugged in. So there's the machine. And I'm going to go ahead and just kind of show the monitor as well. Turn it on. And if you can see the orange LED on the front of the computer, that actually indicates that it's in non-turbo mode. That's the way it comes up by default. So let me go ahead and move the camera over here to the screen. So now that's ready to go, I think also, if you notice, I've got two speakers plugged in here into a small amplifier. Just some test speakers that I use for doing a few things. What I'm going to do is I'm going to go ahead and launch Space Quest 3, and I've already installed it before, so it's already set up to use the ad-lib card. And in this case, it's actually going to act like an OPL2 because this program, when it came out, the OPL3 didn't even exist. So let me just go ahead and show you what that looks like. Make sure the volume's up. With the turbo off, it takes a little longer to launch. You can see how slow that's drawing, but the sound's actually working all right. You know, in fact, I'll just hit turbo now. Should start making a big difference in speed. It stopped because I hit the space bar to go ahead and start the game. And there's Roger walking around. I'm going to turn turbo off again. You can see how much slower he walks. And then back to turbo. Oh, I guess I didn't make it off the screen. There we go. Yeah. Well, I'm going to go ahead and quit the game. Alright, so that's just kind of an example of what you can do with different games, and pretty much any game that supports ad-lib should work just fine with this card. Later games started coming out that supported OPL3 mode, and I still need to do a little bit of experimenting to see how it behaves when I set it to port 220. I'm a little concerned that the Sound Blaster hardware is different than the OPL3 implementation specifically, although from several data sheets I read while I was researching this card, it said that in many cases the Sound Blaster cards and different versions of them would support OPL3 sound, and it would use port 220 to address that hardware. But knowing that there's a few more things going on with the Sound Blaster, I haven't actually tried that yet. But there are several programs out there that support OPL3, and I'll just show you one other one that's a MIDI player, and just to give you an idea of how the stereo sound might work. There are stereo microphones on my camera, but you know, there's not a heck of a lot of good imaging here, so it's possible that it's not really going to sound in stereo, but just be aware that these applications are. There's a batch file that I've written. This is an application that I found online. I forget the name of it now. It's just a small MIDI player. But I wrote a batch file in here which tells it to use OPL3, tells it not to use XMS memory because there is no XMS memory on an XT, and it's just a quicker way for me to launch a MIDI file. So let me just do this one. And if you see over here, the application actually detects that it's an OPL3. And the port that it's on. Okay, let me do a different one. And these are some demos. I forget where I've downloaded them, so I apologize, but I'll go ahead and slow the machine down to non-turbo. Now I think it's starting to affect the playback a little bit. You can hear how notes are dropping, but if I go back to turbo. Alright, so let me just do one more. There was a better one in here, I think. I don't remember the number now. Well, anyway, I think you get the idea of what different MIDI files will play back, and like I said, this will work with any old DOS game that supports the ad-lib, and with some experimentation, and I'll post some future updates as I have time to play with it more. At this point, I've been really focusing on getting the hardware completed, which thankfully we've finally done. But one more thing I wanted to do real quick is, since there was no software to support 4-channel sound, there really was never a way for me to know if this 3rd and 4th channel were working. So I wrote an application, not a very good one, but one that would actually activate the 3rd and 4th channel as well as the first 2, just to show that the card is actually doing what it's supposed to do. So before I plug them in, let me just show you this application real quick. I just called it Resound, and it comes up and it asks you what port you want to use. By default, it's set to use 388, but since you can set the jumpers on the card however you like, go into this program and test it real quick just to see if it's working. I'll probably make the source code for this available, but like I said, it's not the greatest program in the world. It's just something that I hobbled together real quick just to get something working on the 3rd and 4th channel. But right now, without the 3rd and 4th channel plugged in, what I'd like to do is just show that the application is going to try to play things on the 3rd and 4th channel, but since there's nothing there, you just won't hear it. And I'll just type 388 in here. There's the rear channel, which is doing nothing. The other rear channel, which is doing nothing. turn it down a little here. Okay, so as you can hear, anything, the left and the right channels, front channels worked. The left and the right didn't this time, so I don't have them plugged in. Then the test for the front 2 speakers worked, the rear 2 failed, and then the all 4 channel test just shows you the front 2 channels working. So now I'm going to take this other amplifier that I have and plug it into the back. Let me just show these guys real quick. All it is 2 little PC speakers that I have plugged into a headphone amplifier. It actually doesn't take a lot of power to power these guys, but now that all 4 are plugged in, I'll try to zoom out so you can see all this stuff hooked up. It's going to be difficult to tell, I know, which speaker is making what sound, but what you'll see now is that I have the other 4 channels plugged in. I'll go 388, and then off it goes. And as far as I know, that's the only application in the world that will support the rear 2 channels for the moment. But I'm hopeful that as game developers are continuing to write DOS games for the vintage market, someone picks this idea up and can actually support surround OPL3. I will say, just as a quick note, if anyone's actually done any app development for the OPL chip, in particular the OPL3, the left and the right channel and the rear channels pretty much behave the same way. You can't really set volume or have panning effects or anything like that on the OPL3. It's fairly straightforward. You have a number of instruments which you can define in order to make different sounds, and what you can essentially do is assign those instruments either to the right channel, the left channel, or both channels if you wanted to have it work that way. There's really no other feature like that will give you better control. And likewise with the rear 2 channels, it's just an option to enable them or not enable them. You could create surround by taking a few special instruments and just assigning them only to the 3rd and 4th channel for rear effects, and likewise with the front channels, which I'm sure some people have done quite a few times. But just be aware that, you know, while it supports 4-channel, while it supports stereo and all that good stuff, the OPL3 itself is relatively limited in how it can use those functions. But that being said, it still would actually work fairly well for sound effects and other things that were going on, you know, behind you and so forth. So I think it could add an interesting layer to the DOS gaming market. And there's one other feature I wanted to mention too, which I think I forgot to mention that when I was showing the board. If you noticed on the top of the board, there are 4 input pins. These are actually laid out very much like a input for a CD player on the Sound Blaster would be, or anything else. So the idea is in the future we plan to make a few different sound cards. I have a couple of different ideas in mind, and I hope to have an output on those other cards, and that way if you have this one you can just chain them together and have all of your sound come out one speaker. And one other note to mention is that the op amp is actually doing roughly a 2-to-1 gain. The signal coming out of the sound chips, the DACs themselves, is pretty hot. And since it was hot, I decided just to keep the noise levels low, to keep the gain to 2-to-1. I saw in a lot of other cards they would do 2-to-1, 3-to-1. That seems to be relatively common, and I opted for the lower amount because honestly everything I plugged it into creates a nice loud signal. The voltage seems to be roughly what it should be for a line level output. It may be on a little on the low side, but if I went to 3-to-1 gain, it's a little high. So 2-to-1 worked out, and I could use nice round values of 10K resistors on all of the op amps for the output. But if you want to change that, you know, I'm going to post the schematics for this board, as well as the application that I've written, all the notes that I've taken along the way. I hopefully can compile all that together for something useful for people to look into. But let me go ahead and show the back of the card real quick. Alright, so here's the back of the Packard Bell. I'm going to go ahead and remove the video cable here real quick just so we can see the sound card a little better. And here it is, and this is the top connector is the right and left channel, and the bottom connector, and here's the little headphone amplifier that I have plugged into those speakers just to give it a little bit of amplification. So there's the sound card, and if you'll notice, I've got the holes cut fairly large in here around the audio jacks. These are just standard 1/8 inch audio jacks, stereo. The left and right channel for the front channels are here, and the left and right for the rear are on the bottom. So if you're only using the front 2 channels, you can just use the top connector and just not even plug anything to the bottom one. As you can see, the connectors are about 2 millimeters from coming to the edge of the board, and as a result of that, they're sticking into the metal just a hair, which isn't a huge problem. But what I had to do was I drilled the holes around them larger, so that when you plug in your connector, it actually seats all the way properly, and the rubber piece can seat in there a little further. I do intend to fix this further down the road. It was just unfortunately something that I had fixed, and then I reverted it. But normally these plastic connectors should be sticking out just past the board, and the hole will be smaller. It's really cosmetic at this point. It's not a huge problem. That's why I went ahead and decided to run these, because frankly I've been working on them 3.5 months, and I've just been trying to get them out the door because I know there's some interest already. I've had people mailing me randomly asking, hey, why don't you make an OPL3 sound card? And little do they know I was actually working on one. But you know, the internet being what it is, I don't like to announce things until they're ready, and here it is. It's ready. When I make the next run of boards, moving that connector back forward about, I think it's 2 or 3 millimeters roughly, that it's back and recessed. But for now, I just had to drill the holes a little bigger. One other note, you may notice these holes are a little bit off because they're not dead centered, and you can blame me for that. That's me versus the drill press. And if you've ever used a drill press for an extended period of time, you know that trying to drill into shiny metal, inevitably the bit's going to walk a tiny bit off of your center mark. So as a result of that, some of these holes are a little askew. But rest assured that you'll be able to plug the connector into all of them just fine, just like in that one. I'm going to double check for that, so it won't cause you any problems. Just a little bit of a bigger hole around it than I would have liked, but otherwise no real problem. Certainly feel free to check our website, toselect.com, for updates. Thanks for watching, everyone, and have a great day.